All right, so we're going to make a reactive field here. And the first thing we're going to do is we're going to make the field. We're going to make it in such a way that we can change the number of elements without changing the uh, the size. And what that means, let's establish some parameters here. Let's do integers. Let's say we want a size in X. We want a size in Y. We want a num points X. And we want a num points Y. Okay, let's say 48 here. Let's make that 12. Let's make that 24. Use this little line and distribute. Everything nice and neat. Oops. Cool. All right. So this is going to be our origin. And what we want to do is we want to move it in X. I'm going to get a parameter here. And you'll see why in a minute. Vector, and let's call that size. And so instead of just hooking the size up to the X vector component, we're going to do it a little bit differently. And again, you'll see why in a second. We're going to set the amplitude of that vector with that size, and point, and bring your origin in, and we'll go under move. So there we go. So that basically takes that basically will take a point in and it will move it according to this this vector. But what we actually want to do is we want to create a line of these points. So let's change that here. Let's go math, and what we want is, sorry, it's under sets. We want to create a series of numbers, and we want to start with 0. And the number, so let's call this num points. Right. So that's going to be the count. Right, so if that's set to 12, now we get 12 points. That's counting 0 to 11, because remember in Grasshopper, we always want to start counting from 0. And then the size, right, is going to be, so let's say size. That is going to be the number of points. Go back to math. It's going to be the size divided by the number of points. All right, so now we get a series of numbers. Oops. Size is Ah, so I put that into the wrong step size, right? So this is counting by, so now we're going to be, right, 48 divided by 12 is 4. So this says count by 4. So you can see 0, 4, 8, 12, right? So we get 12 numbers starting at 0, but we're ending at 44. We're not ending at 48 because what we really want to do, here, I'll show you, right? If we hook this up to here, right, now you can see we end up getting, right, we take our 4 integers, we take our vector, so we get 12 vectors, or 12 integers, we take our vector, we get 12 vectors, then we use that to move our point, right? But now we're getting 12 points, or what we, but they end at 44, because really it's the number of spaces that matter, and the number of spaces, right, is the number of points minus 1. So let's just do this. Let's say number of points minus 1. All right, so now we're dividing by the number of points minus 1, so you can see we still get 12 values. We got 12 hooked up to our count, and we've got the size divided by the number of points minus 1, which gives us numbers from 0 to 48. So now we've got 48 points. Sorry, 12 points going from 0 to 48, which is the size that we want. Cool. All right, so that's the size, that's the num point, that's the number, that's the vector. This is our point out. Now we're going to want to do the same thing in Y. So wouldn't it be great if we could reuse this? In fact, we can. So we're going to highlight all of this. And we're going to make a cluster. We're going to call this point array. All right. I know I spelled points wrong. And so now what's cool about that, right, is if we copy this, we still want our origin, but this time we want the vector to be y. We want the size to be the size in y and the number of points to be the number in y, right? So now we're getting this, but the problem is it's still not a grid. So as you can see, right, when you've got one value like this x vector, you get a single line. When you're getting a list, you're getting a double line, right? Because it's a list of 12 points. So here's the trick. What we want to do is change this from one list of 12 points. If we use graphed, simplify, you can see that now, right, if we hook this up to something, we get these little like hot dogs. And now it says it's 12 lists of 1 point, which is kind of weird, but it's really useful because if now we put this into our point part of the cluster, you can see what it's doing is it's saying for each of those 12 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here, down here, right? It's saying treat that as the input to our cluster, which makes a point array using the y value. And then what we get out of here, we're going to simplify again just because it cleans up that little number next to it. Right now we get 12 lists of 24 points, right? So each one of these 12 is now a new list with 24 points going that way. And if what we want to do, which we often do, is we want to just turn that into one big list, what we can do is we can hit flatten. So I'm going to save this. Save it on my desktop. You should save it in the right place. And we'll call it field 25, 10. That's right. Okay, so these are our new origin points, right, for our field of objects. We can turn, right, we've got we can just turn all those things off. So the next thing we want to do is maybe we want to move those points around um, according to their distance from some other point or some other points. So let's create a point here and let's reference it in. Let's call this points. Let's call this Attractor 1. Set 1 point. Okay, so right, like we could draw a line from each of these points to this point. What we want to do is we want to get the distance. Let's start. Um, and what we're really interested in is we're really interested in the smallest value and the largest value. So what's the closest distance and what's the furthest distance? And so here's one way to do that, because right now what we're getting is we're getting a list of the distance from every point to that attractor point in the same order as the points. But the first thing that we want to do is we want to sort that list. If we sort that list, then use the very, very useful list item to say what is the first item. And you have to remember, again, in Grasshopper, we always count from 0. So the 0th item is the first item. So that is going to be the minimum. And then what we want to do is we want to get the maximum. And well, one easy way to do that, instead of trying to figure out what's the last number in the list, because maybe the number of items in the list will change, is what if we just reverse the list and then get the first item again? So you can do that in a couple ways. You can do that with the reverse list. You can also do that by clicking reverse here. But if you do both, um, it'll just get it back to normal. But let's click reverse. And then that gives you the max. And then what we're going to want to do is we're going to want to put it into the special form called a domain, which is just essentially like a chunk of a number line. Because what we're going to want to do is we're going to want to remap from our own set of values for how high or low we want our new set of points um, based on the minimum and maximum distance from the attractor, which of course changes, right, every time we move the attractor point. But what we want to do is we want to, and this will make more sense when I just do it. So why don't I do that? So here under domain, what we want to do is construct a domain, right? And if we mouse over this, we can say that's the least small value is 2.11, large value 72.6. And the domain gives us, it just says one domain from 2.11 to, what was it, 72.6, something like that. And we can get a parameter for that. We can call it domain. Here we go, domain. You know what? Let's make this a cluster too. Let's call it distance domain. Now the nice thing about clusters, by the way, just to prove a point, is that when you edit one, they all change. Right? So if we go in and we wanted to do something, we can double click on it. And if we wanted to do something like bring back that line, and make that an output, right? If we copy this little flaggy thing here, right? Even if we turn this off and then we click save, right? You can see that this one updated too, and now we have a new output that we could use to get those lines. Super useful, especially when you want to do things, sort of things you want to do and do over and over. And then if you change it, you only have to change it one time. Okay, so let's say we want to get we'll call this minval, and we're going to call this maxval. So the minimum we want to move it is maybe 1. The maximum we want to move our points maybe 12. We want to go back and we want to create a domain for that. Domain. Let's call this Attractor domain. And let's call this move valves domain. So now what we want to do, right? We've got our right. What we really need is we really need the list of our distances in the same order as the grid point. So let's go back in here and let's maybe get rid of this. But let's create a parameter called distances, right? And let's get the output of that, hook it up to this. Okay. Oops. Wow. Let's show this message again. What did I do here? Let's try that again. Right, that's a number. Distances. Okay, save. All right, now we got our distances. So what we want to do now is we want to remap numbers. There's remap numbers. We want to remap those distances. So let's say like for this one that's like very close, let's use something closer to 1. For, I don't know, this one that's probably the farthest distance, let's remap that to 12. So our source domain, right, is the distance from our attractor, right? The numbers that go from 2 to 72. And the target domain, that's the domain we want to remap to, right? So now we have a list of numbers that go from between 1 and 12 based on how far they are from the attractor. Right? So what we want to do now is we want to get, like, let's say like a z vector. Let's call this distance. And we want to move. Let's get our grid points again. We want to move our grid point based on the distance from the attractor in z. Cool. But actually, maybe what we want to do is we want to move it up when it's higher, when it's closer. So, meaning if it's more like 2 away, we want it to be, more like move up 12. And if it's more like 72 away, we only want to move it up 1. So what we're going to do here is we're just going to shift. Now we got, now we've got that. So cool. So if we want to, right, what we could do, um, right, is we could turn this into a cluster too. Right? We could select those, select these, cluster, and we could call this shift points. Because maybe what we want to do is maybe we want to have a second attractor. I'm having trouble typing here. So maybe what we want to do, see, 2, right? And we'll use that one. Oh, where'd our tractor go? Let's go back in here. Oh, I see. Um, so just like we did with the output, what we can do with the input is we can copy one of these little flags and put it there. And then let's save. Now it breaks because it doesn't have an input. That's Attractor 2. Let's make this Attractor 1. We'll say set 1 point, and we'll set it to be that point. Right? So there we go. We've got our thing again. And then this one is Attractor 2 to that point, right? But now we have two sets of points, which is not really what we wanted. But what if we just use the output of this one to be our grid points for this one? Cool. So now, right, we're using the effects of 2 attractors. What if we set this to -10? Right, you can see what's happening. Um, so let's try one more thing, just because I think it's useful. What if we want everything? I'm gonna turn off the preview on this. Just bring back 1 here. What if we want? See how it's kind of relatively smoothly falling off? What if we want to fall off a little bit more sharply? So one thing we could do. So here's our distances. Right? What if we took our distances and we raised them to a power? So where is it? Where is it? Math operators power. There we go. And we made that its own parameter. Let's call it pow. Let's give it a point. I'm gonna save here. All right, so now we've got this pow. Like, what if we raise it to the second power? Go in here, right, and we use that as our distance. So now it's saying, right, we go from, oops, we want, ooh, I made a little mistake. Can we do this? Let's see if we can do this also to domain here. Nope. So we need to also edit uh, this guy. So we need to get the distance, and we need to raise that to power. So let's get rid of this. Oops. We forgot to add our little flag input guy here. And now we're going to stick that into here. So what we're doing is we're saying, take these two sets of points, find the distance between them, raise them to this power, and then use that as your distance output, right? See how we just basically inserted this component here, which will raise up the distance to whatever power we decide. All right, so now it's coming right out of there. Got to reconnect this to our remap. And that should work if we set, so you can see if we set this to negative 0.2, raising it to the negative power, right, you get this, oops, sorry, not negative 0.2, just 0.2, right? You can see how it's falling off really sharply. And if we set that to 1, it's just as if we'd never done this. If we set it to 0.5, right, it falls off a little bit more quickly. And because we made that change in the clusters, right, we made it to this cluster, which is inside of the other cluster, right? Now that change happens everywhere. So we have to go back. This one is breaking because it doesn't have power. Add one there. Right? And then we can turn this off. You can see that right now we get these sort of much more dramatic effects um, in terms of raising and lowering um, our our grid. So we also use this remap. If you remember in class, what we did was we started to draw some lines between, oops, the, not the attractor, between the original grid points, there you go, and our new points. And then what we did is we used a similar kind of cluster. We would evaluate that curve. And then right, so now I evaluated that curve a quarter of the way up. And then let's just move it. Let's move them all the same amount. And let's move them all X. Right, so now we shifted them all. And then what we could do, then we did something like this, where we would take that's our first point. Right? This is our second point. I'm holding down shift. Oh, but let's do this. What we need to do is do the trick where we graphed again. Simplify. And then here again, right, we have a list of 288. If we graphed and we simplify, now we have 288 lists of 1. And then over here, that's our top point. We're going to graphed, and we simplify, right? And now, because we turned each of these into 288 lists of one, but when we hold down shift and dump them to one parameter, now we get 288 lists of three. And if we do something like, use one of these guys, right? Now I'm going to turn off the preview on that. You can see that we have these nice curving lines. So this part right here, right, what that part is doing, I'm going to group it. That part is, creating the line between the top and bottom and then evaluating it according to this parameter. Oops. If we change that parameter, you can see my line changes a little bit. Right, it makes it closer to the top. And then we're building up a curved line by saying, take the bottom point, make it into 288 lists of 1 point, take this middle point, make it 288 lists of 1 point, do the same for the top, combine them into one, and then you get 288 lists of 3 points. And then what we did is we made a new little form by saying we want to take where is it? It's a pipe, variable pipe. Right, but we also need curve parameters for the radii. I'm just going to do this really quickly. If I say multi-line data, then I can make our curve parameters 0, 0.25, and 1. And let's remember to make sure we click reparameterize on that. And then we also need 3 radii. Let's make them 1.5 and 0.01. But we need to say multi-line data. Oh, no, it was multi-line data. Right. And then the last thing down here is if we say for the pipe, if we make that a 2, we get round bottoms. Let's do that. 2. Now I should have saved before doing this, so let me hit save right now. Because the cool thing, right, is, and this is the whole reset this way, is now if we want to change our number of x values, right, the size of the field doesn't change, but the number of points changes. Now I did this in class in a little bit more detail. Um, but what I would leave up to you as an exercise, right, is how you could change this part of the definition so that you could make everything move instead of having to say it all moves by 2, which gives us this very uniform thing. Make it move according to its distance from another attractor, which means that you maybe need to change some things about shift points so that you can produce values or rebuild it. You could also rebuild it, like you could go inside and you could select all the things and then save it. And then, paste them out here. Oops. Right. And then you could use this to rebuild a different component or a different cluster. And if you change it, it won't be linked to these. Um, you could rebuild it so that you could make this part of the definition make the shift happen in a variable way based on um, a different attractor point. And so the last thing I'm going to do, maybe I'll we'll get a B rep because that's what these are. B reps are things that have more than one surface. Um, and you can flatten it if you want so that it's not a list of lists. So let's look one list of B reps. And if you bake it, all right, we just open up a new document. We turn this to rendered. Maybe should have tamped down the number of these, but there we go. There's our little droplets.